All right, evaluating a definite integral from 5 to 8 of 1 over x squared, our reciprocal squared function dx. So in doing this, because our x is in the denominator and the exponent on x is not a 1, what we want to do first is probably rewrite this with a negative exponent. So we want to evaluate from 5 to 8 of x to the negative second power dx. And in doing so, what we can do is now use our power rule. So we're going to go ahead and increase the exponent by 1. So negative 2 plus 1 makes negative 1. And then typically we think of this as divide by that new exponent. So I'm going to initially put this as 1 divided by negative 1, which we can simplify down in just a second. All right, so we've taken the antiderivative. We want to evaluate this from 5 to 8. So 1 divided by negative 1, I'm going to think of that as negative 1 out in front. And I'm going to first rewrite this with a positive exponent again. So that x to the negative first power, I'm going to make that x to the positive first power down in the denominator, evaluated from 5 to 8. And in my next step, I'm going to go ahead and replace the x with an 8 first. So 1 over 8 minus, now I'm going to replace it with a 5, so negative 1 over 5. Now really this is negative 1/8 plus 1/5. But we can get a little bit better answer than that. To do so, we would need to get a common denominator in order to combine these fractions together. I think in this case our common denominator is going to be a 40, so we're going to go ahead and multiply the first fraction by 5 over 5, and the second fraction by 8 over 8. And this should give us like negative 5 over 40 plus 8 over 40. Keep that common denominator and combine our numerators together. So negative 5 plus 8 makes positive 3. That won't reduce down any further, so that's a great exact answer. Let's leave it just like that. Hope this helps out. Good luck as you're working through these.